Cherian. It's my pleasure to welcome this afternoon Alexis Noel, who is the Product Manager Digital Services Milling Solutions from Bühler, Utzwil. With his presentation for us this afternoon is moving towards predictive maintenance with temperature and vibration management, TVM. Alexis, welcome. And as we say in Kenya, karibu sana.
Thank you, Kemal. Let me share my screen. Thank you, perfect. So today, first of all, thanks a lot for the invitation. It's an honor to come here virtually and to present. Hopefully we'll be able to do this live very soon again. So my name is Alexis Noel. I'm a product manager for digital services at the Bühler Group, so working in milling solutions. And so today I will talk a lot about our latest service, but I was very happy to learn when Martin Schlauri, that probably you know, we also moderated yesterday, when he told me that this is not just a commercial presentation, that I will really have the time to go in the details, look at the data, and then show you millers how we can support you and having better operation and running everything to make it easier and also safer for everyone. So thanks a lot, and let's get to it. So throughout the years, there was many waves of technological innovations that has made milling more efficient, easier, and let's say more also profitable. But still, to this day, there are some unsolved challenges. So we listened to the industry, went to the miller, then we always hear the same thing. So we want the right product with the right quality, the right quantity, of course, and at the right time. Very important. And this can sound like an easy job, but on the way, there are actually many roadblocks. So breakdowns, for example. So your maintenance strategy will have a massive impact on how you can handle breakdowns and how it will actually allow you to get these requirements fulfilled, the right quality, quantity, and right time, because a breakdown can really shift your entire production, and then you have only unhappy customers. So already a good maintenance strategy can help, but I would say even more so. My colleague Blair talked a lot about maintenance yesterday, but the best maintenance is the one you don't do, actually. If you can avoid it, avoid the damage, I would say it's even the best, even better than predictive maintenance. Maintenance avoidance is probably then the ultimate goal. We don't want to do it. It needs to run. Now, also more and more requirements. So regarding traceability, handling different raw material. Traceability, for me, it needs to be something that runs in the background, that we don't need to care about. It's in the back, it works. Whenever it's needed for an audit, then I put it out in 2 clicks. And I think we are doing a lot of progress here in this field, and definitely this service that I'm going to show also supports and goes into this direction, so that everything's recorded. Then you can just, when there's an audit, just show the auditor, okay, on this date, this time, here's what happened. Easy. Now, another topic that I think is becoming more and more important, it's energy. So energy prices are rising everywhere. And I know that for most millers, it is a topic, but it's not usually the most important, right? When you look at the cost structure of a mill, it's usually, so the energy is definitely not first. Raw material is definitely first. Energy comes at the bottom. But I think there will be a big change there. So we want to electrify everything at the moment. We want electric cars, electric planes, and the demand for electrical energy is increasing. And at the same time, we also want to transform the way we produce energy. We want to have it more green, less carbon emitted. And in the end, what will happen is somebody has to pay for it, right? So energy prices will increase, and it will become more and more in the future a topic. So here, I just want to make this clear. So if it's not in your priority list, you can believe me, it will be in the future. And I think all the solutions we are trying to develop within our digitalization strategy also at Bühler is always going these directions. We want better use of resources, but we also want less energy consumed in the process, which is both profitable and also good for the planet. So last but not least, people. I think skills availability is becoming more and more an issue. And I would be even more provocative. I think it always has been an issue. I don't know any milling company in this world today that can afford to have their best miller 24/7 inside the mill in front of each roller mills. It's just not possible. So physics does not allow it. And I think that here with the service that I'm going to show you and show you in the details how it works and then what you can do with it, we will see that we can address some of these issues. Of course, the service is definitely not going to solve everything, but it supports and it's an additional building block on fulfilling all of these requirements. So now let's take a step back. I'd like that we reflect, let's think of a roller mill, right? Let's look at the temperature over time on a single point taken randomly on one of the two rolls of a pair. Now, what do you think will happen? When the roller mill is running, stable production, I'm not talking about startup or emptying at the end, no, stable production, how will the temperature evolve? We could think it will stay constant or they would vary, but actually what we noticed in our experiments and in our labs is that, yes, the temperature will vary a lot, and we didn't have any tool to measure it actually until now. So how it looks like, basically, just depending on how much products goes in, on the milling passage, for example, a smooth passage will always be hotter than a corrugated one. Depending on how the roll gap is adjusted, you will also have different temperatures. And what we have also noticed is that once you cross a certain threshold, then it becomes critical. It becomes critical because it has an impact on the quality, on your stability of the quality, but also on the yield, on the extraction. It has a huge impact on the energy consumption. So the hotter you operate your rolls, then the more energy you will consume. And of course, when we add more energy in the system, there will be more wear. So the rolls, the surface will get damaged even faster, which means in the end, more maintenance, more downtime, not a quality as good as you could expect. And this, at the end, multiplied by all your roller mills on the bottom line can make a big difference. So that's what happens in a roller mill. So you always have these variations when it's not controlled, and you cannot do much about it. Even more, until today, you could not even measure it. So now, what we want to do is, because there's this critical area, there's also, how we defined it, the optimal grinding area. It's where you stay within an upper and a lower limit of temperature, where you get the quality you want, so that you can set yourself for your product, and then where you consume as little energy as possible. And this consuming as little energy as possible will also have a positive impact on the maintenance, because you will use your rolls less, and then you will be able to keep them running for a longer time. So that's actually what the service I will talk about today is about, making sure that all your roll mills stay in this optimal grinding area, and that you use the data to stay there for a better operation. So TVM, if I didn't explain yet, is about temperature and vibration management. So it's our new latest service. So now, this was all a little bit theoretical, but how have we implemented it? Because we cannot measure everywhere, every single point on the surface. So what have we done? So we have put sensors inside the roles. So there is one sensor inside each role in a pair, and they measure during the whole length, on the whole length. So they're on one side, and then with the rotation, then you kind of have the temperature distribution over the whole length. And on top of this, we also measure the vibrations with the sensors. So the sensors are placed directly inside the rolls. So it's completely new. And last but not least, because these sensors are just one part of the service, where the value really is in the algorithms that will allow you to always stay in this optimal grinding area and detect when you get out of it. As I said, it's not that easy because corrugated passages and smooth passages don't behave the same. You have a lot of influence from other parameters, and you need to extract all of these. And we have done this through machine learning, data science, and to really extract what's needed and then provide the right alert to the operator, to the miller. And we'll go into all these details later, because yeah, we really have the time for it. I'm very happy. And it's also running on our Bühler Insight platform, because we need a platform where our algorithms can run, right? We cannot do it on site directly, because they always improve, they learn with the data. The more data we collect, then the better they become. And yeah, so now I will show you some of the features of the service. So here you can see the main ones, but there are actually a lot more. So you can see that we have automated over temperature detection. Once you go above a certain threshold, we send you an alert. This is more, let's say, for safety. In the future, we'll also be able to shut down the plants. So this is when it's really hot. When you get a little bit outside of the optimal grinding area, it doesn't make sense to shut down the plant. We just give an alert, and then yes, things can be readjusted, and then you can go back in the optimal grinding area. But when it becomes really critical, there, you need to shut down the plant. Now, what we have also developed is an automated detection of temperature imbalances. And I will come back to that. We'll go into real examples, real data. Then I will show you what imbalances really mean. Of course, another feature is temperature and vibration visualization. So you can also use this raw information for your own benefit. If you have some ideas, things you would like to test, this data, of course, is yours. And it's always possible to have a look at it. Also very interesting, I will also show you later a concrete example, is product winding indication. So we are able to detect when the product gets stuck on the surface of the roll. And then we will see what are the consequences of this. And at the moment, it is possible to detect it only when somebody is in front of the machine and has the luck that, yes, okay, it happens when I'm in front. Otherwise, these cases just go unnoticed, and I will also talk more about that. Now, also what I want to say, all the notifications and alarms are also included as part of the service. You can get them through emails or through SMS even, so that even if you're moving around the plant, then you can also be alerted, and you can also select during the shift so that you only get alert when it's your shift, right? And not when you sleep, for example. Now, very also interesting feature is the benchmarking and trends. So of course, you can use this in a single plant, but it also allows you then to have very precise process control and to produce, for example, same recipes in different meals, and then at the end obtain the same quality. We know it's a challenge for some of our customers that they have quality differences that sometimes are unexplained, and this service supports then goes into this direction. And here I want to say that, so yeah, grinding is one of the most important thing in the mill, but it's not the only thing, right? So of course, it will not fix everything. If the dampening is wrong, then the service cannot really help, because the other things also need to be right. Now, this is only the beginning. So as I said, because we set it as a service now, all the new features, all the new algorithms we will release, they will be actually included. And I think this is really important to understand this. We have actually a lot in the pipeline. We already released a lot, but there's even more coming. We will, for example, to give you an insight, we can discuss this at the end also. Wear level prediction on the roles. This is something that with the data we have found a big correlation. We'll discuss this later. Grinding force distribution. I mean, temperature gives us directly, it's very much correlated to the grinding force. And this is actually great with our new integrated grinding system, Arias, where you also have grinding force measurements, but only on the two sides. And now we're on top of this service, then you would have the entire distribution available for you. And then we also have some long-term projects where we want to look at mass flow disturbance, because we can actually analyze. So when there are mass flow disturbance, so what I call when there's, for example, a lot of product coming and then a little bit less and then more, these things we'll be able to analyze and make sure that the mill stays at the design operating point. Because when you have this mass flow disturbance, this can create a lot of issues also in the plant sifters. And so we have this on our radar for a more long-term feature that we will develop. So here you can have a look at how it will look like actually on our Bühler Insights platform. So this is only the detailed view that you will be able to have for each of your role pair. So you can see on top the fast one, on the bottom the slow one, the slow roll, and then you see the temperature, and then on each side also the vibrations. And this is a detailed view, so the raw data. But then we also designed an overall dashboard that can tell you within 2 seconds if your entire plant is actually adjusted correctly. And then the roll pairs, the passages that are not correctly adjusted, they will pop up automatically. And then you will be able to see them and then very quickly also do something. So in case you don't even have access to the alert, then you can check the service and then you see, okay, yes, my plant is running at the right level. I have the peace of mind. So now let's go more into the technical details. So these are the sensors we're using. So these are long sensors. Of course, we have different sizes because we have different sizes of rolls. And so we measure temperature on the whole length, which means that for a 1 meter roll, we have about 9 measurement points. And then for 1,250 millimeters, we have 11. And then for 1.5 meter, we have 13 measurement points, which gives us roughly 1 measurement every 10 centimeters. We have 1 vibration measurements on the left edge, which is usually enough because vibrations are also transmitted. So also from the right side, we are able to detect it. We put 1 sensor in each roll, which means that for each passage, there is 2 sensors actually. And also the sensors are also, I'd say, a little bit smarter because they run on a battery. So we need to optimize how the data is transferred. And when we are within the threshold, the data is sent every 5 minutes. And then once the temperature increases and then can become critical, then of course we want to increase the frequency at which we transfer the data. And so, this, of course, we don't have to wait 5 minutes. So the sensor reads it, and then if it's already increasing, then it sends it directly. It doesn't have to wait 5 minutes for the next measurement. So it's really the data transfer interval and not the measurement interval. And these thresholds are, of course, customizable because we need this customization because all the different milling passages are operate at a different level of temperature. What is critical, for example, for a C2 smooth passage is not the same as what is critical for a B1, for example. And so since they run on battery, we could think, we have to change the battery very often, but it's actually not the case. So it's designed with Bluetooth low energy. So then the expected battery life is over 5 years. So of course, we have not run them for 8 years yet because the sensors are not even 8 years old. But that's what we expect when we use them for a few years, then took them back, measured the remaining battery life, and then it gives us around 7 to 8 years in some cases. And yes, so this is already available now. We released this in last March, and now let's have a look at some more case studies in details. So can we detect uneven and faster roll wear? So that's a really good question, because usually how we do it, and we look, we feel maybe with the fingers the wear level of the rolls, and then maybe we do it at one location. But that's really interesting, because depending on how the rolls are operated, they will not be worn out the same way everywhere, which can be a problem. You may think a roll is running, let's say, okay, it's good condition, but then you didn't check the left side where it's actually very worn out, and then you're consuming too much energy, losing throughput, and so on. So can we detect this? Actually, yes. This is caused by temperature imbalance from one side to another. So here we talk left to right or right to left. What this creates is an uneven granulation over the whole length, an uneven roll wear, additional energy consumption, because you just consume more, you're pressing more, and it's not what a brake passage, for example, is designed to. You have a loss of throughput because you have recirculation. Some product that should have been reduced in size is not, and then it has to come back. And of course, this impacts your bottom line in the end. And here we can see really in the data directly. So on the blue lines represent the left edge. So the more blue, the more left. And then when it becomes green, then it means that actually it's the right edge, the green part. So here we can see a big imbalance, about 30 degrees, let's say, from the left to the right. And then we said, that was during our tests, and we just told the operator, look, we call him, you have a big imbalance, please do something. So the operator was also kind of blind. I didn't have access to the data. And then, so he adjusted, and then he told us, yes, okay, now it's adjusted, fixed. Thank you for the tip. That's fine. And then we check the data. And what actually the operator has done is a complete opposite. So we can see here during the adjustment, now it's the right edge who's running at a much higher temperature. And this is because the operator was blind. You can maybe if there's really a big temperature difference, you can feel it with your hands. Probably 30 degrees on the product, you can feel it with your hands. But then to adjust before the temperature then adjusted, then that it finds its new equilibrium. No way to do it with the hands. So you really need the service, because then the sensors are at the closest point ever measured in the milling industry. So you measure really what happens during the grinding. And there you can say very quickly, okay, is it adjusted correctly or not? And this is, for those of you that maybe know the temperature bar we still have at the outer part, so outside of the rolls. These are more for safety. We tried to use this for process improvement, but there's just no way. You don't get the correct temperature distribution there. So they're the best methods we could get. The best results, the best temperature distribution is actually with these roll sensors, as we call them. So the one inside the rolls. So that was our first case study. Also really telling that, yes, okay, the service can bring something, but it also needs to be used, and it's kind of also a transformation of how the operator works, that they also rely on the service. Of course, service will tell you, yes, there's an imbalance, but we have also seen with some test plans that, yeah, if you don't act on it, then it's useless. Of course, you really need to rely on the data for your decision process. And if this is not implemented, then the service will also be useless. That's definitely for sure. Now, let's talk about the second case study. Here, it's also something we can detect. So we had the imbalances side to side, but we can also detect, we can even be more granular because we measure every 10 centimeters, we can detect temperature imbalance middle to the sides. And that's a really interesting one, because these issues are, to my knowledge, almost never recognized by the operators. And it takes really experts to figure out that what is wrong in the end. And here we can really support on this part. So here you can see real data shown a little bit differently, because last time we showed you was only on a few hours, few minutes. Now it's really over a month. So let's imagine this is a roll. Here you can see, so that's the left side, position 0, and then the right side, 1 meter. So this roll is 1 meter. And then we checked over a month how it's running. So all the blue lines, it's when actually the mill is not running. It's the ambient temperature. Roll mills are shut down and it's not producing. And then when it's colored, then it's, you see, it's during production. And you see that from June until October, actually, it was really warm in the middle. And what this shows us is that you're not grinding your product the same way. So it's either you only have product in the middle, or maybe your roll crowning is wrong, or maybe the adjustment is also wrong. It's hard to know before you have a look, actually. But now what we've said, we went on site, discussed with the operator, adjusted the feeding gap, and then we see then the production running much more stable. And the consequences are actually the same as before from the side to side. You have uneven granulation. You're not using the entire roll length that you paid for actually with your roller mill. So you're losing throughput, consuming more energy for nothing, because these sides are also rotating and not producing as much as in the middle. And then you also wear only the middle part much more than on the sides. So it's really not smart operation. So once we adjusted this, informed the operator, then this was fixed. And then we can see that it's also sustainable, that over a long period, because now you know, you can check, you are aware of it, it's implemented in your adjustment process, and then it's clear. You can finally get the benefits. So in this case, it was the feeding gap adjustment. So on top of the feeding. Now, it could have been the roll cambering, for example, and this then would have need to be changed at the next refurbishment. So another very important case is the over temperature detection. Here we talk more about safety. So once we reach a very high temperature, this can become very critical. It can damage the roll surface. Of course, process becomes very unstable. If it happens one time for 5 minutes, then you should be fine with your product. But if it happens very often, that you don't notice it, then it can be critical for the safety of your assets, for your people also on site. And also it will cost you a lot, of course. And you also relatively also consume a bit more energy. So what we can do here is actually inform you proactively, so when it happens, so that you know very quickly, okay, there's something wrong there. You can adjust the level at which you want the alert. And then if it goes really high, so let's say at even more critical level that you even suspect the fire, then we are working on the next feature that will also be able to shut down the whole plant. So now I would like to show you this also interesting case about winding that I mentioned earlier. When the product gets stuck, then what happens? You can even have products going out, some damaged parts inside. So the consequences can be also really severe. And can we detect it? The answer is clear. Yes, we can detect it. And we can detect it because of two things. So the temperature goes up, but then how do you distinguish like a temperature going up in one case and in the other where it's caused by the winding? Then the answer is through the vibrations. Once we see the temperature increasing and then also at the same time vibrations going up, and then we see that these two matches, then we are almost sure it's a winding indication. So at the moment, we have not found any other root cause for that. Every case was winding. And that's what we say now, winding indication. So yes, it's a safety risk. You can damage your asset. So what happens is the product gets stuck, and then at every rotation, it's kind of shaking the whole roller mill. It's consuming more energy for your product quality. It's also not the best. I mean, same happens, you're losing then also stability. Now, if it happens one time for 5 minutes, then it's fine. But what we have noticed is that when it happens on a roll pair, it will also happen again many times in the next weeks. And this comes actually in this case that we investigated, because the data will not tell you exactly what to do. It will tell you possible root cause, but then there still needs to be human behind, relying on the data for their decisions. And in this case, it was really about adjusting the scraper knives that was wrong. And once this was fixed, it was solved. But really, this can be critical, because if you damage your asset just because you did not adjust it correctly, the scraper knives, this can become very costly and damage the bearing also and reduce their lifetime. So, and by the way, all these cases that I mentioned were not even recognized by the operator when he's in front of the machine. So there's really an additional benefit that you can detect stuff that were not possible to detect before. Here, I want to talk a little bit about what's coming in the future also, what we call vibration in suspend. So in suspend means for us that when the rolls are disengaged and then they are still rotating, so it's still running, so it's a suspend mode. And here we can actually run kind of a health analysis on the system and have a look at the vibrations. Is it normal according to what it should be? Because it should actually be the same for every roll mill. And this we know because we also build them. And once we detect this stuff, we also tried different cases. So for example, loose bolts on cardan, we can detect it through the vibrations. Inadequate belt tensioning. So if the tensioning frequency is wrong, then we can also detect it. And this is also very interesting to kind of monitor the health of your machine and then have the proper actions in place to fix it. So it's here we really go, it's really predictive maintenance. So we detect what needs to be done in advance and not have a periodic check that you do every month, and then sometimes 90% of the time it's maybe already good. So that's really interesting. We could see all these cases on the data, and now we're working on really automated, so health check whenever it's in suspend, that we have a look at the data and then can inform directly the operator, so he doesn't have to check on the service directly. That was also a very interesting case. It took only 2 hours here. So you basically you have the smooth roll, how it was looking before, and then you have the new smooth roll, let's say, even smoother than before. All of this because the scraping knife would not adjust it correctly, and very interesting for the operator. He was in front of the machine. We called him, told him, look, there's a problem here. We see it on the data. And then in front of the machine told us, no, I don't hear anything. So the vibration sensor is much more precise than the human ear. So we are able to detect critical operating conditions that the human ear or eyes or fingers cannot detect. And this is here quite interesting, because I mean, this roll is good for refurbishment already now. Otherwise, you can also keep it running, but then you will consume more energy. It will impact your quality, and in the end, you're also not winning. So as I said in the beginning, the best maintenance is probably the one you don't have to do. So now let's have a look. So I've shown you quite a lot of a case study, but then I always get the question, okay, what's in it for me? What can I expect? And this is always very difficult to answer, because it also depends on how you are running today. If today you already have the most optimized mill, then I would say probably the service is not for you. If you think that you can improve, that you can put this service into your continuous improvement program, then the service is for you. And I can assure you that most mills I have visited, we always have potential for improvement everywhere. And here I want to show you exactly what you could expect. So it's first, energy consumption. I've talked a lot about it. I think it's really important. More and more in the future, it will become important. And there's really a clear benefit there. If you can lower the temperature to the minimum that is giving you the quality that you want, you can really decrease the energy consumption. So here I say overall 8% in the milling section. That's what we measure at one customer, but on specific passages, so the hot passages, let's say, these, if you can decrease temperature even a little bit, this will have a huge impact, and you can have savings up to even 20%. So of course, this needs to be done carefully. You don't want to impact your quality. You also want the right quality, but then you can really have it, you have a tool to measure. And if you also have a modern roller mill or then additional measuring equipments for energy, then you can see it instantly. You reduce the temperature and then you see clearly a reduction of the energy consumption. Second one is a little bit more tricky. So additional uptime. So we believe that with the service, each recipe change can be handled much more efficiently, and you can reach the stable optimal level much faster. So then it will reduce your your startup times and also less back and forth with the lab. So this also depends on how you do it today, right? And also if you change recipes very often. If you always produce one recipe the whole year, then probably this line will probably not be there in your benefits. Now, there's also an additional benefit on uptime is when you don't have to change a roll pair, so you don't have to shut down the mill. I know it can take up to half a day to change a roll pair. I've also done it myself once. And clearly, so if you can avoid it, base maintenance is the one you don't do, then you also get an additional uptime there. Now, clear, there is a maintenance benefit. So I would say if you never have issues, then probably there is no maintenance benefit. But it means that you're also putting a lot of effort into preventive maintenance. Maybe you also monitor your bearing sensors very closely, and then you try to do as much possible condition-based. So it's a lot of effort. And here you can, there's also a maintenance benefit if you see potential for improvement. So for example, so the optimized wear level due to the correct temperature will mean that on average, for this example, so 300 ton per day mill, you will have one less refurbishment per year and less spare parts to buy. So this is especially true for the hot passages. So C1, C2, C3, for example. Now, also interesting is the miller's availability. So you want to use your skills then to really do valuable work, and going in, taking samples all the time, checking passages. It's time consuming, and now this task can be automated. So it's now possible to focus on really the highest valuable tasks. So this is clear. We expect, let's say, half a day per week extra availability. Also depends on how much recipe change you're also doing in your operation. So this should be calculated actually for each mill, and we also can support there with the calculation. And since we also expect a better quality stability, let's say, then we also expect less recalls from customers. And this only you can estimate, okay, do I have a lot of recalls already today? Or am I producing for maybe one customer, always the same recipe, and then it's easy? Maybe you have less recalls. It really depends. But so these are, it could be that in the end you get more, and it could be that on certain lines in the end you get less. So these should be calculated for each mill and then see if it's worth it to install the service. So to summarize a little bit my presentation, I would like to say that this service really is helpful to detect critical operation conditions very early. So we can act in the mill in advance before the critical things happen. and it impacts the production and worst case also in order to preserve the assets. So second point is also the consistent product quality that we want to get with, of course, the lowest energy. So the service will help having lower energy consumption, higher throughput, and more optimized operations. So here we're really looking for the last percentage of gain you can get. Now, since this is also a tool relying on people, right? It's not all automated. Still, somebody needs to have a look at it and take the right decisions based on the data. Then your knowledge of the grinding will also get better. For the first time, we have sensors at the closest point of the grinding, and there will be, we can learn. It's also an opportunity to learn what each recipe, what is the optimal temperature level for my quality. And then once you have this knowledge, then you can actually transfer it to your other plants and then learn faster and get even more benefits. Last one is the data transparency. As I said, benchmarking, looking at your temperature level across different milling lines that you probably have, and then help standardize the quality, having the same high quality for all of your customers across different production lines. Also very useful on existing assets. Service is also available for retrofits, which is the highest market probably, and yes, it's also available there. So with this, I would like to close this presentation. Thank you a lot for listening. I'm here for the questions. And if you also want more details, please feel free to contact me or my colleagues. And yeah, I'm here for your questions. Thanks a lot.
Alexis, thank you very much for your interesting presentation. And in the spirit of kicking off the question and answer session, I'll do that first, and then we'll open it up to the floor. Yep. So I'll go straight. I mean, there's a big list of benefits that the TVM is offering us. Is it really possible to achieve everything, all of it?
Yeah, I would say there is always potential, but the potential to achieve all of them will vary depending on how you are currently operating. If you already have, let's say, you think you have optimized everything, then maybe the benefit will be lower. But we always see that some mills have strong points, some have weaker points, some are really good on the quality consistency, and then a little bit less on the energy side. And we can see that, yeah, it's actually possible to have both, but we just didn't have the tool until now to achieve it. So it's always case by case. We need to calculate it.
Interesting. And as the TVM initially stands the way it is there any future plans to expand the role that TVM will cover for us as millers? Any additionals that we'll be looking at?
Yes. So I would say installing the service is also investing in the future in a sense, because we plan a lot more integration. For example, with our integrated grinding system, Arias, we will always release some of features that will be, of course, whenever possible, available for all the TVM users, but there will also be premium features that we will include with our latest machines. That, for example, we can combine all the data we get from the Arias grinding system, and then also develop the new solutions that will also go into the same direction. So better detection of critical operation condition, and then easier management. So I would say, to be very precise, one of the clear goals we have now is to implement also in the future the automated gap adjustment. So we already do it electrically. Also recipe change we can also adapt on the latest roller mills, but now what we want to do is really process optimization. So even during the process, it will do it at a much higher frequency to adapt the gap.
Right. Thank you, Alexis. I'll pass it back on to Sherian to pick up the questions we have off the floor. Thank you.
Yeah, thank you, Mr. Kamal. So we received already one question from Ahmed. He's asking, what is the distance between the sensors and the rolls? The sensor's efficiency, will it be reduced to the dust accumulation by hanging the rolls? The sensors needs to be disassembled.
So Okay, so first of all, so the sensors are inside the rolls and there's a cap, so also ATEX certified, so there will be no dust inside. And so the sensor is located a few millimeters, centimeters from the surface. So we are not in the drilling in the hardened part on the roll surface, we're just below in the steel, in the normal steel of the roll. So in this case, it's quite safe in a way that there will be no dust, and even in case of sensor failure with the battery, something wrong happening, then your product is also safe, and the closing mechanism is also certified. Now, if it can be disassembled, yes, the sensors can be removed. We also do it during the refurbishment standards. As we can see, the lifetime of the sensor is much higher than the lifetime of the roll, let's say. So then there's no problem. You just change it at the next refurbishment. You don't have to stop the machine one more time just to change the sensors.
Okay, thank you. And another question from Isa. So it means with existing rolls, we cannot fit TVM?
Yes, we can actually. So there's nothing that needs to change on the rolls. We usually advise that the service to set it up to do the retrofit at the same time that you buy new rolls, for a simple reason that you can drill existing rolls, but the problem is you're investing into a used asset, the used rolls that you will not last as long as a new one, and then does not really make sense in some cases. Depending on what are the costs for drilling, then it's really usually better, depending on the drilling costs, to just buy a new roll and then do it, let's say, over long periods. You don't have to come in, set up everything with the sensors, and then it's a big investment. No, every time you replace some rolls, you can retrofit the sensors. It also works.
Okay, thank you, Alexi. I don't see new. I can see now a new question from Antonio. Can we fit sensors on brake rolls as well?
Yes, absolutely. So this service works on brake rolls. I talked a lot about smooth rolls because they're also the one consuming the most energy. But then we also about the maintenance. When you talk about recorrugation, then of course brake rolls are important. We can also detect it, and yes, it also works too.
All right.